And now we'll turn our attention to the last topic here, the topic of trigonometry. Trigonometry is very, very important for us to understand both in Calc 1, Calc 2, and actually Calc 3. Trigonometry makes large appearances in all of these courses. And so if you're planning on being in the calculus track for a while, knowing your trig is so crucial. So if you don't know some topics with trig, there are some things that you need to review. This is a good way to go ahead and actually try to start looking over this material and making sure that you feel comfortable with it. So there are really two types of things that we need to make sure that we are well prepared to do as we move into our second unit. The first would just be computing some basic simple unit circle trig values, like what's the cosine of 7 pi over 6 and what's the secant of 4 pi over 3. Now those can either be dedicated to memory, or you could understand how exactly we construct those values at every moment. And I'm going to leave it to you to go ahead and actually compute those on your own. And if you need help in terms of recalling how to actually do that, by all means, please let me know. But the other thing that we need to be able to know how to do is to set up trig ratios and relate the variables of different sides of a triangle using different trig ratios. You might remember certain kind of memorization tools like SOHCAHTOA that maybe helped you to recall how trig ratios were actually set up. So I'm going to go ahead down here really quickly and just highlight some important ideas associated with our different trig functions. Remember that if I'm working in a triangle and I'm taking the sine of a given angle, the ratio of sides of the triangle that are going to actually result in the same value as the sine is the opposite side over the hypotenuse. If I'm working with the cosine, I'm going to be working with the adjacent side of the triangle over the hypotenuse. And if I'm working finally with my tangent, that's going to be the same thing as the opposite over the adjacent. Now when I deal with my other trig functions, that is if I deal with something like the cosecant of an angle, or the secant of an angle, or the cotangent of an angle, I should recognize that first off, these are all kind of paired up with a partner kind of on the other side here. So cosecant goes very well with the sine function and the sine ratio, and it's really just going to produce the reciprocal ratio, since these were reciprocal functions. Same thing with the secant and the cosine. They're just going to produce reciprocal ratios. And finally, the cotangent is going to produce a reciprocal ratio of the tangent. So when I take a look at parts B and C here, let's take a look specifically at 5b. I need to be able to go ahead and set up a trig ratio to relate the variables in the triangle that's on the left. So I'll notice that I have an angle, I have a side that's opposite of it, and I have the hypotenuse. So when I look down here, I can see that actually the sine or the cosecant would both be valid ways to actually set up and relate the sides of the triangle without having to do any extra work to solve for the missing side. So I could state here that the sine of theta, if it's equal to the opposite side over the hypotenuse, would be equal to 1/2 over 5. Of course, I could rewrite that as 1/2 times a fifth, and so this would actually just be 1/10. If you wanted to, you could also, though, use the cosecant of theta. That would be the same as 5 over a 1/2, also known as 5 times 2 over 1, and that's a total of 10. Notice I just end up with reciprocal values. So this would be a perfectly valid way to tackle something like number 5b. And in number 5c, you're asked to ultimately do the same exact thing. Notice, though, that it is important that these are right triangles. Keep in mind that trig ratios here are only going to hold, or they are only true, in right triangles. So this is actually important because we'll see that at times we may wish that we had a right triangle in some of the sections to come, but we may not always. And if we do have right triangles, we should feel very lucky because it gives us options that otherwise we wouldn't necessarily have. So go ahead and try to practice the same idea by attempting part C, and of course you may want to continue again to brush up on being able to calculate different trig values like I have listed here. Of course, if you have any questions or if you need some extra review materials to help you kind of recap on your trig, by all means please let me know and I'd be happy to pass along materials to assist you.